Hello guys, good evening. How you doing? You are welcome to another edition of my YouTube tutorial videos. Okay. Today, by God's grace, we'll be taking a topic on calculus, which is exponential word function. Exponential function is very easy. It's not as tough or difficult as most people think it is. Okay, it's one of the easiest aspects in calculus generally. Okay, so now we have a question here. We are asked to find the y, the x of the following. Exponential function question is very easy to identify because it normally carries what? Exponentials. Okay. Now, this very question, we have question number one. Okay, for question one, we have y equals to what? E of x. Can see they say exponential function is still under what? Functions. Okay, we are still applying formula for functions of what? Function. Okay, now the truth is whenever you differentiate exponential of a variable, you still have that same thing. For example, if you have e of a, exponential of e of s written as e of s, exponential of e of a is written as e of a, exponential of e of p is written as e of p, exponential of e of t is written as what? E of t. Okay, exponential of t. So it doesn't change, it remains what? The same. So having this in mind now, so all this shouldn't be what? Difficult for you to what? To solve. Okay, yeah, we have the first question here. Okay, so we have y equals to e of x. So now dy dx is written as what? E of x. That's it. That's it. Very simple. Then y for number two, we have y equals to e of 2x. Okay, now to solve this, okay, what you need to do, you assign a variable to this. You can say let t, or let's use p. Let p equals to what? 2x. You differentiate your p in respect to x. So here we have the p over what? The s equals to what? If I differentiate 2x, it's as what? 2. Okay. So here our y is equal to, you rewrite the question in terms of p equals to e of everything here is written as p. If you differentiate y in respect to p, we have dy dp equals to what? We still have what? E of what? P. To get the y dx is just for you to multiply these two what? Together. So our dy ds is equals to dp over ds times dy over dp. So dp over ds is written as what? As 2. While dy over dp is written as what? Ep. So 2 times ep, we still have what? 2ep. And we know what our p. Our p is written as what? 2x. So our final answer will be 2e2x. Now it's very easy. You know your normal differentiation. If you differentiate x, is it not 1? 1 times everything here, you still have that same thing. Just like this one, if I differentiate 2x is 2, then you use that 2 to remultiply everything again. You have 2e2x, the same thing. So having that mindset, you should be able to solve other ones. So let's move straight to question number 3. So for question 3, we have y equals to e of x minus x. So our dy ds is equal, if I differentiate e of x, it's as e of x minus, if I differentiate s is what? 1. So that's the final answer. So y for number 4, we are giving y equals to e of minus x. E of minus x. So what do you do? Okay, you should know that differentiate minus x is minus 1. Minus 1 times everything here, you have minus e minus x, or e of minus what? X. That should be your final answer. But you have to show your what? You have to show your workings. Okay, so how do you solve this? You say let p equals to this. So let p equals to minus x. You can use any alphabet of your choice. Okay, so now if you differentiate p in respect to s, we have the p over the x equals to minus 1. So what do? You rewrite the question in terms of what? P. So our y is equals to e of minus s, that's what? P. So here we differentiate y in respect to p. So the y dp is certain as what? E of p. It doesn't change. So to get the y dx is for you to multiply these two things together. So our dy ds is equals to dp over ds times dy over dp. So the p over the x is written as what? Minus 1 times dy over the p is written as what? EP. So minus 1 times EP, we have minus EP. And we know what our P. Our P is sitting as what? Minus 1. So our final answer will be equal to minus E of minus 1. That is minus E of what? Minus what? X. So that should be our final answer. So why for question number 5? For question 5, we are giving y equals to E of minus 5x. If you ratio minus 5x, your answer is minus 5. Minus 5 times everything there, you have minus 5e of minus 5x. That should be your final word answer. What I'm telling you like this, okay, maybe you have an objective question, you shouldn't waste time solving. But in terms of theoretical part, you have to show your workings. So what do? You assign a variable to everything there. You say let what? Let u. Sorry, you can use u anyway, but I prefer using p. Let p equals to minus 5 what? X. So here our dp over the x is equals to, if you differentiate minus 5x, is sitting as what? Minus 5. So here we rewrite the question in terms of p. Our y is equals to e of everything there is sitting as p. So dy over what? Dp is sitting of e of p. So this time around, to get the y over the x, to multiply these two together. So our dy over what? The x. Dy over the x sitting as dp over the x times dy over the p. So the p over the x is sitting as what? As minus 5. Then times dy over the p is sitting as ep. Minus 5 times ep, we have minus 5 ep. And we know what's our p. Our p is sitting as minus 5x. So our final answer will be equal to minus 5 e of minus 5 what? X. So that should be our final answer. So let's take the last question, which is exponential of root x. Now we have exponential of root x. How do you solve this? Okay, remember you say let what? Let p equals to what? Root x. Okay, you differentiate your p in respect to x. But before that, you need to break down your root. Root is sitting as what? Is sitting as half. Then if it's cube root, it's sitting as 1 over 3. Fourth root, 1 over 4. Fifth root, 1 over 5. So and so on and so what? Forth. So what do? You have to break down this question. How do you break it down? This is sitting as p equals to x raised to power 1 over 2. So this time around, what do? You differentiate your p in respect to what? To x. So we add the p over the x, then equals to, this is sitting, I have a visible one here. That is 1 times 1 over 2. So we have x. Then here we have 1 over 2 minus 1. So from there, 1 times 1 over 2, we have 1 over 2. Then x. Then 1 over 2 minus 1. This is over 1. Look for the SN, which is what? 2. SN of 2 and 1. 2 times 1 is 2. So here we have 1 over 2x. So 2 going to 2 is what? 1. And 1 times 1 is 1. 1 going to 2 is 2. 2 times minus 1 minus what? 2. All over what? 2. So here we have 1 over 2x. 1 minus 2, we have minus 1 over 2. So this time around, if you break this one down, this sitting as 1 over 2, then times this sitting as s minus 1 over 2. Remember, half minus this sitting at 1 over 2, then times here is sitting at 1 over x half. And s is sitting as what? Root x. So this sitting at 1 times 1 is what? 1 all over 2 root x. Okay, now everything here, half is what? Root. So that's why we're having what? Root x. So 2 times root x is what? 2 root x. So now that you've gotten what? The p over the s, you rewrite the question in terms of what? P. So our y is equals to e of what? E of p. So the y over what? The p is sitting of e of p. Now to get the y, the s, for us to multiply the two to what? Together. So our dy over the s is equal to dp over the s times dy over what? Dp. So from there, our dp over the s is sitting as 1 over 2 root x. Then while dy over dp is sitting as times what? Ep. So 1 times ep is sitting as what? Ep all over 2 root x. And we know what's our p. Our p is setting as what? Our p is setting as root what? X. So our final answer there is going to be equal to exponential upon root x all over 2 root x. So that should be our final answer. So that's all. So thank you very much for staying tuned for this exponential word function. So stay tuned for our next topic, okay, which is implicit word function. Please don't miss the class. Thank you very much. Please ensure you like, subscribe, and share to your fellow friends to learn. Bye.